So here's an example of how to work the population variance and how to put the standard deviation to work that I was referring to in the lecture YouTube video that hopefully you just watched. So here's a little group of numbers for us to put to work with the formula. And you can see that there's 1, 2, 3, 4, 5 scores. So we have an N of 5. And just like I showed you on the slides, using the formulas, the sum of squares formula, which I have summarized right up here in the upper left-hand corner, we're going to use and keep consistent with the three-step process throughout the entire semester. So step one is that using the computational sum of squares formula, sum of x squared minus sum of x squared divided by the n. Step two is to calculate the population variance, which is to just take the number that you generated in step one and divide it by the n, however many scores you have. And then in step three, to get the standard deviation, you're just taking the square root of the variance. So once you have the variance number on your calculator, just put your finger over the square root button and punch it, and then you'll have the standard deviation. So with the preliminary building block numbers, you see that I've calculated them here. So the sum of x is 23. Then we squared each of the x values and came up with sum of x squared. Summed those squared values up, in other words, and then squaring the sum of x, 23. 23 times 23 gives us 529. And I've put those numbers into our 1, 2, 3 step formula. So 143 minus 529 divided by our n of 5 works out to 143 minus 105.8, which works out to a 37.20. And then that's the sum of squares, so you just put that into step number 2, the sum of squares of 37.20 divided by the n of 5 gives you your variance. And then if the variance of 7.44 is entered on your calculator, then just take the square root of it, and that's where 2.73 came from. So here in this box is the definition of the standard deviation, the average distance that score values are from the mean. And it's the most practical measure of variance that we use. And we use it to frame the interior of the bell-shaped curve, which is what we're going to take a look at next. So one thing I didn't cover was to take the mean of this group of 5 scores. So 23 divided by 5 is an average of 4.6. And remember that the mu is the symbol for the population mean. And to put the standard deviation to work, we create a bell-shaped curve, and then we put the standard deviation lines on the interior of it. And that's customary to put 3 standard deviation lines to the right and 3 standard deviation lines to the left of the mean. So that's what I've done here, and I've identified the center line as representing the average. It's the measure of central tendency for this particular group of scores, and we calculated it up above as 4.6. And then using the standard deviation increments of 2.73 to the right of the mean, I added 2.73 to 4.6, and that gave us 7.33. And then 2.73 added to 7.33 gave us 10.06. And then 2.73 added to 10.06 gave us that 12.79. And to the left of the mean, instead of adding the increments of 2.73 or adding the standard deviation to the mean, we subtract it. So 4.6 minus 2.73 is where that 1.87 comes from. Minus 2.73 gives us a negative 0.86, and so forth. So what this does is allows us to create a context for our data set, for our group of scores. And it frames the group of scores so that you can, when you place the individual score values along that horizontal axis, like I've done here, these are the 5 score values that were listed in our X data set up above, then you can get a sense of how many of them fall plus or minus 1 standard deviation from the mean, or plus or minus 2 standard deviations from the mean. In other words, It just puts the scores from your data set within a context that will allow you to determine which scores are atypical or unusual, or in other words, are falling very far from the mean, which may be meaningful to us as we continue our analysis, or which scores fall very close to the mean. Plus or minus one standard deviation where 68% of scores fall. Most scores typically fall plus or minus one standard deviation from the mean. And that's what causes the bell and the bell-shaped curve.